Jai Hind all of you. In today's lecture of software engineering, I am going to discuss the important topic of Unit 3, that is about software design. We know that it is the more creative place where we will design our requirements. In designing, it is very important to prefer the modularity. That it is not necessary that we have to work in a one single go. We have to divide our work in small sub parts and finally combining them. So when we are working on the modularity, we have to focus on two basic concepts, that is coupling and the cohesion. Coupling is stating that how the two modules are interrelated, the degree of dependence. And the cohesion states that the dependency, the interconnectedness of a particular data or the flow of data within a module. So let us start with firstly we will discuss the coupling. It is the measure of degree of independence between the two modules. As we can see, Module A is here and Module B is here. Module A is communicating to the Module B. It is sending some information to B and it is also sending back the information to the A. So we can say it is a measure of relative interconnection among the modules, right? It is the connection among the modules. Got it? Or we have understood that coupling, it is the process way of interconnectedness. Now the issue is that the coupling is highly between the components if they depend heavily on each other. We will say the coupling is high if the components, they will communicate between the two components, between the two modules more. That means there is a lot of communication between them. The coupling is said to be loose if the few dependencies are between the components. So we should promote the less coupling. So that will go for the, if we are having the less coupling, so it will promote the maintainability, adaptability, since as if the change in one component is more less likely to affect the other. If the coupling is less, that means the change in one component does not affect the another component. Here we have designed how the coupling will look. If we are having, say I am having M1, M2, M3 and it is M4. Say. Here the four modules are there, but they are not connected with each other. That means there is no dependencies and these four modules are uncoupled. Now let us look this picture. Again, I am having M1, M2, M3 and M4. Right here. Here we have seen some kind of communication between the modules M1, M2, M2, M3, M3 to M4, M4 and M1. So here some dependency is there. So we are having some loosely coupled, some dependencies are here. Now look at this. See, the highly coupled, every component is connected to each other in many ways. So many kind of dependencies are there. There are the several types of coupling we will have. The couplings are like contained coupling, common, control, stamp, data and many more. We will define here the content coupling will be the tight coupling, that means more interdependency. Tight coupling, that means we are having the high interdependency, more coordination and more information flow will be here to the content. Where as we go back, the loose coupling is there, right? Less interdependency is there, less coordination is there, less information is there. Let us start with the first one, that is data coupling. So the data coupling modules are the two modules are coupled like if they communicate through a particular parameter. That means the coupling exhibits the properties that all the parameters to the module are either simple data types, or in the case of a record being passed as a parameter, all data members of the record are required by the module. Say for example, any kind of elementary data item can be passed as a parameter between the two modules. Any kind of item like an integer value or any kind of float value or any string value that I can pass. See, look here. Here is one module, here is another. Now the couples, how that we have to retrieve the information, right? When we have to retrieve the information, we will send the customer ID. Then back we will receive the customer address. Here we are coupling. The data coupling is here. The retrieves a customer address using single one item. So this kind of coupling is known as the data coupling, and it is loosely coupled. It is coupled with the one single data item. Or we can see here that here we are sending the two variables here, right? And we will be working on it, or we can write like this here by using this particular code. We are having a structure and we are having all the variables. So we will be passing and returning only primitive data types, not all. So that is really needed for the functions. Now the functions are more general. So the data has been coupled only for the weight and the integer, not for other variables also. Another type of coupling, we are moving upwards, that is moving towards the more coupled, that is towards the high coupling. The stamp coupling occurs between modules when data are passed by the parameters using some data structure. That means the information is increasing. Previously we are sending only one data item. Now the information is increasing. Here what I am sending, the customer information, I am sending some details, like some other details, not only one, and we will in return I am receiving the customer address. Here that retrieves customer address using only customer ID, which extracted from the parameter named the customer details, right? There is a one parameter named as a customer detail. Never pass, but make sure if we have to pass any data, make sure that you should not pass the data structure containing many fields to be passed. Like if we have to pass, we can pass 2, 3 or 4, but not more than that. Like here, I am just passing the rectangle. So we are passing the entire rectangle to this function, even though the function really does not need to modify all the members, right? All the members I don't need to. What I need, the width and the length only here. Another type of coupling is your control coupling. Module A and B are said to be control coupled if they communicate by passing any kind of control information. Like this is usually according to the means of flags that are set by one module and reacted upon by the dependent module. Okay. So the control coupling exists between the two modules if the data from one module is used to pass any kind of the order of instructions. Like we have to set one flag set as any one value when it has been tested, right? And we will send it to the another value and test it to the another module. Here it is an example. I am passing the customer ID along with some information type, and in return I am receiving the customer name or the customer address, what else information I do needed. So in this example, the module retrieves either customer name or the customer address depending upon the flag value that I have illustrated here. If I am sending the ID and the flag value what I have illustrated, depending upon whether the customer name has to be sent or whether the address name has to be sent. Like here, or we can say if there is a command dot equals draw circle. That means command dot equals function, if I am passing as a draw circle, then it will invoke this function. Otherwise, it will invoke draw rectangle. It was like this only. So this kind of modules is there. Suppose I am passing any information in from the one module to for invoking the another module. That kind of situation will arise and it is known as the control coupling. Other one is your common coupling. Two modules are common coupled if they share data through some global data items. Common, the word has been used, the common. If the two or more modules are sharing the same global data items, then these modules will be known as they are common coupled. That means all modules have the read and write access to the same global data block, right? Module will exchange the data using a global data block, and this is the strongest form of coupling. That means the more dependencies has been increased. Suppose we are having a same global data, right? A, B, C, and it is accessed by all. Say M1, also by M2, M3, M4, M5, right? It is say M3 also accessing B. So it is more coupled. It is more highly coupled form. Global data is here. Say global A1, A2, A3 variables and V1, V2. It is a common data area and where the common area variables. Say if I am having these three modules, say X, Y and Z, if the V1 to 0, right? V1, the value of V1 will be changed to 0, right? And module Y is incrementing the value increment V1. And what the module Z is getting? It is getting the value V1 as a V2 plus A1. For this has to be done, the value of V1 again changed, right? And we have changed the value of V1 to the 0. Now we are having the two kinds of value. That module X is what the module X is doing. It is changing the value of the V1. Module Y is incrementing the value of V1. But how the value of V1 is changing by the module Z? It is doing V2 plus A1. So all the three modules are accessing the same variables. Or I will say in a global variable, if it is greater than 0, we can say switch the variable. If the case 1, function A, function B, and in other variable, the global values will be incremented again. That any kind of particular. So here function A and function B can modify the value of the global variable. Then it can extremely difficult to track the execution of this particular loop. Every time the values has been incremented. The most coupled type is your content coupling. The content coupling exists between the two modules if they share the code along with, say for example, a branch from one module to another. Complete code has to be shared. Previously we have started with the data. We are just sending the item. Then we have started with some data structure, and again we have gone to the with some information and along with some flag information, right? So now the size of data has been increasing that we are passing. Now we have jumped to the complete. What we are passing, the complete, a branch from one module to the another module. A module directly references the content of the another module. So a module is allowed to access or modify the content, say for example any local or private data item. So this is the strongest form of the coupling. Say module P modifies the statement of module Q if the P refers to the local data of a module Q in terms of any kind of numerical display. So the module P branches to the local label of the module Q. Let us understand with this example. Here it will occur when the module A changes the data of module B, or when a control is passed from one module to the another. Say in this given figure, module B branches into the D, even though the D is supposed to be the under the control of the C. देखिए यहाँ पे change होगा, यहाँ पे change हो रहा है, but it is under the control of C, though it has been, B is also changing the value of the D here, but it is also under the this particular module B also, like this. So module B and module D. We have seen, we are considering this is our best data coupling. The data coupling is the best considered, and your content coupling will be considered as the worst one, right? So controlling the number of parameters passed among the modules. How we can say we can achieve the good coupling? By controlling the number of parameters which has been passed among the modules. Avoid passing undesired data to the calling module. If that data is not required for that particular module, no need to pass another undesired data. Maintain parent-child relationship between calling and the call modules. Pass data, not the control information. As we have seen, it is better to pass the data, not always to pass the control information. This control information should be identified, should be judged before calling your another data, right? Now coming to the another part of the modular design, that is cohesion. We have talked about the coupling, where we are talking about the closeness of the two modules. Now we will discuss about the cohesion. It is a measure of the internal relatedness of the components of the module. The interrelatedness, how the modules are internally connected, how well the design units are put together to achieve the particular task. So we will define the cohesion as the measure of degree to which the elements of a module are functionally related, elements of a particular module, how they are internally related. There are some categories of the cohesion, like informational cohesion, functional cohesion, communicational cohesion, procedural, temporal, logical, and coincidental. High the cohesion and low cohesion. It is just reverse of the coupling, the degree of the cohesion, right? What we need? We need the high cohesion. In coupling, we need the loose coupling and the low cohesion. That means low cohesion, that means the module interrelatedness of the interrelated information flow is very loose. High, that means internally the flow of information is very high. Let us understand with these examples. Like if I am saying coincidental, that means the parts are unrelated. Say this is one module, it is having function A, function B, function C, D and E, and all these parts are there. All these are coincidental, they are not related. So this kind of cohesion is an example of the coincidental. Then logical, function A dash and the function A double dash. Function A and the function A dash is similar functions by logic. Then function A and A double dash are again the similar function with some logic, some similar functions. Then here the sum of the functions are related with the, sum of the parts are related with the time, and this kind of known as the temporal. Time t0, then t0 plus x, t0 plus 2x, t0 plus 3x, it can be any. Procedural, A, B and C related by the order of the functions. Order, the first function A will execute, then function B will execute, and then function C will execute. This is the order of the function. This is what procedural. There is a quite difference between the procedural and the sequential. Look at here, sequential and the procedural, the two things are there. Procedural, that means it is saying the function A will be executed first, function B will be executed first, and the function C. But it is not saying that the output of the function A will be the input to the function B and the output of function B will be the input to the function C. It will happen in sequential form. The output of one is the input to the another. Communicational, again with some global data, right? Some global data or some data store that we are accessing the same data. A, B and C both are accessing the same data. This is communicational. Then coming to the functional. Function A part 1, function A part 2, function A part 3. Sequential with complete related functions, right? With complete and related functions. एक ही function है आपका part A, part B and the part 3. So this is your functionals. Let us discuss all the cohesions in detail now. Information cohesion describe a module performing a number of operations, each with a unique entry point and independent code, and all the operations are performed with the same data. Here the module is performing a number of operations, each will be having a unique entry point and independent code, and all operations are performed on the same data. So in information cohesion, each function in a module must perform exactly one action. Like here, it is an example of information cohesion. Airplane is there, the private some values. This particular, we have given 3 functions and all these 3 functions will be taken off. Like if the takeoff is there, then fly function must be used, and if flying is there, then land will also be called. So all the functions will be called. Functional cohesion, it is stating that the functional cohesion is said to exist if different element of modules cooperate to achieve a single function. The different elements or the parts of a module, they will cooperate with each other to achieve a single function. And for every essential element to a single computation is contained in the component. Every element in the component is essential to the component. Then coming to the sequential cohesion, I have told you earlier also, module A outputs some data which forms the input to another module B. So this is a reason for them to be contained in the same procedure. The output of one part is the input to the another. The data flows between the parts occurs naturally in the functional programming languages. Then another one is your communicational cohesion. A module is said to have a communicational cohesion if all functions of the module refer to or update the same data structure, right? Set all functions defined on the array stack, communicational, right? Same place से same access हम कर रहे हैं, we are doing the same. So the functions performed on the same data or to produce the same data. So example, update a record in the database and send it to the printer. Update and sending for the printing. That you update a record and print the record. Or some unrelated data items like to minimize the disk access also. Procedural is there. Sequential and procedural, there is a quite difference. That means there should be the some procedure that when a software components are grouped into a module to perform a series of functions following a certain procedure to achieve specified by a some application requirement. So the elements of a component are related only to ensure a particular task. Like actions are still weakly connected and unlikely to reusable. Say we can take example, if we will write output record, something has to be written, then only something has to be input, right? That what has to be given, the output has to be given, only the new input record has to be read. Then only the input record has to be padded with the spaces. Then that particular record will return. Then again it will be write another. Then again the procedure of the another new input record will be started. So this is the sequence, or some I will say this is the procedure has to be followed. Then coming to the temporal. When a module contains a function that are related by a fact of the functions must be executed at the same time span, right? The module is said to be the temporal, where the timing elements are related by the timing. Like we are having when the elements are grouped when they has been processed. Like at a particular time when you are going to log in on a new system, the user will be notified at the same time. Lots of different activities will occur all at the same time. Then coming to the logical cohesion, a module is said to be the logically cohesive if all the elements of the module perform similar operations, right? Logically they are related. Say for example, error handling, input, data input, data output. So we can have the example of the logical cohesion is the case where a set of print functions will generate the output reports are arranged in a single module. Elements of a component are related logically, not functionally. They are logically related. Really, that the data input is there, how the error handling will be performed. So several logically related elements are in the same components and one of the element is selected by the client component. Then coming to the coincidental, it is quite similar that in coincidental no relatedness is there. All the parts are working separately in a particular module, so that constructions that have no relationship to another, the grouping does not have any kind of relevance to them. So the parts of the components are unrelated. The parts of a component are not related by their location in a source code. If we can take an example, in a transaction processing system, get input, print error, summarize the member functions are grouped into one module, but they all are not related to each other. So we have seen the several again the cohesion: functional, sequential, communicational, procedural, temporal, coincidental. The worst one will be your coincidental cohesion, but the best will be your functional cohesion. So we have find out. So the cohesion should be high. That means interrelatedness of the communication of data will be high. But in case of coupling, it should be low. The communication from one module to the another module should be low. So what we have identified the relationship between the cohesion and coupling. If the software is not properly modularized, a host of seemingly trivial enhancements or the changes will result into that of the project. So the software engineer must design a module with the goal of make sure high cohesion and low coupling. It is the objective. Look at here. Here are the some components inside one module. Again, here are the 5 components inside this module. The 5 components. They are related to each other. Inner relation is there, right? Inter cohesion is there. But all these components are again related to each other. This is high coupling. Now look here. Components are related to each other but with the low coupling. So we will prefer for the low coupling situation. Low coupling. High, I am saying high because cohesion should be high. Cohesion is high but the coupling is low. So we will prefer this situation, not this. So we have to design it accordingly that the coupling should be high and the cohesion should be low. Thank you. That's all for this particular lecture.